Let's examine a right triangle to understand the Pythagorean theorem. This fundamental relationship is one of the most important concepts in geometry. We'll label the sides of our triangle. The base is labeled A and measures 4 units, the height is labeled B and measures 3 units, and the hypotenuse, which is always the side opposite the right angle, is labeled C and measures 5 units. What makes this a right triangle is this special 90-degree angle, which we mark with a small square symbol. This particular angle is the key feature that allows the Pythagorean theorem to work. The Pythagorean theorem tells us that in any right triangle, c squared equals a squared plus b squared. The square of the hypotenuse equals the sum of the squares of the other two sides. This relationship only works because of the 90-degree angle. Let's verify this with our triangle. We have c equals 5, a equals 4, and b equals 3. So the theorem states that 5 squared should equal 4 squared plus 3 squared. When we calculate the values, 5 squared is 25, 4 squared is 16, and 3 squared is 9. So we have 25 equals 16 plus 9. Adding 16 and 9 gives us 25, which confirms that 25 equals 25. Our triangle perfectly satisfies the Pythagorean theorem, as all right triangles do. It's crucial to understand that the Pythagorean theorem only applies to right triangles. If a triangle doesn't have a 90-degree angle, this relationship between the sides won't hold true. The 90-degree angle creates a unique geometric relationship between the three sides. This precise angle ensures that the area of the square built on the hypotenuse equals the sum of areas of squares built on the other two sides. If we were to change this angle to anything other than 90 degrees, the Pythagorean relationship would break down, and we'd need different formulas to relate the sides. So remember, whenever you see a right triangle, you can apply the Pythagorean theorem to find unknown sides. The right angle is what makes this powerful relationship possible. Let's explore the Pythagorean theorem, which reveals the beautiful relationship between the sides of a right triangle, one of the most fundamental concepts in geometry. In any right triangle like this one, we have a special relationship. The side opposite to the right angle is called the hypotenuse, labeled C in red. The Pythagorean theorem tells us that the square of the hypotenuse equals the sum of the squares of the other two sides, A and B. Let's connect each part of this equation to our triangle. This helps us visualize what the formula actually